Hello everyone. Here we discuss energy and power concept in an electrical circuit. So let's see what is an electrical energy. It is a total amount of work done by an electric current in moving charges through a circuit, or you can say it is the total amount of work done for forcing an electric current in a circuit or for moving a charges through a circuit, and it is measured in joule. Now if we see the definition of electrical power, it is basically the rate at which electrical energy is transferred to a circuit. It is measured in watt. So let's see the energy and power relationship. That power is defined by energy divided by time, or you can say it is the energy is calculated in joules and time is calculated in seconds, or you can say it is measured in joules per second, or it is measured in watts. So if you define this equation, this P is equals to W by T, or you can say E by T. W is the work done. So you can write it W is equals to Q into V divided by T, or you can say it is V into Q by T, or you can say this is V into I. This P is equals to V into I is defined as instantaneous power. It is defined as instantaneous power. It means it is a power in a circuit. It may be a DC source or it may be a AC source. This power is defined by a voltage at any instant multiplied by current at any instant. So for a DC source, this power P is defined by V into I. That means at all instant of time power is constant. For a DC source, this power is V into I. So the concept of power is like this. It is basically differentiated by time. It means for supplying an energy for a definite interval of time, it will given by a power in a circuit. In any circuit, we see three basic elements: resistor, inductor and capacitor. Here we consider pure inductor and pure capacitor. So let's see, in a pure resistor, the supplied energy is transferred in terms of power loss, and in pure inductor the supplied energy is stored in a magnetic field, and in a capacitor and supplied energy is stored in an electric field. And if we see a circuit, there are two type of sources. One is DC source and other one is AC source. So if you see the AC circuit, for AC circuit analysis, power discussion will be discussed in the coming topic with AC circuit analysis, and here we discuss for DC circuit. So let's see. The power loss in any circuit is defined by a simple instantaneous power, that is P is equals to V into I. And you know the power loss is associated with element resistor. In for DC circuit, this power loss is V into I. and this power loss is V into I. V is the voltage across the resistor and I is the current flowing through the resistor. So you can say here we know the Ohm's law, V is equals to IR. So we can write is P is equals to V into I. You can write V by R, or you can say this is V square divided by R. Or you can say P is equals to, from this equation, V is equals to I into R into I, or you can say P is equals to I square R. These powers are measured in watt. So there are three basic formula for the power in any circuit. For instantaneous power, it is V into I, and if you consider a power in a watt for an element resistor, this power is defined by I square R, or you can say V into I, or you can say V square divided by R. This formula is for DC circuit and it is measured in watts. Now let's see the formula for energy in an inductor and capacitor. Energy is defined by power into time. If you see the formula for inductor, this energy is equals to P into T, and power is defined by V into I, that is instantaneous power. So you can write it V is equals to L di by dt into I into T, or you can write it L I di by dt into T. If you differentiate on both the sides, this is Li di by dt into dt. This dt is cancelled, so the inductor energy dE is equals to Li di. If you integrate on both the sides, this is L integration of I di. If you applied a voltage in an inductor, so the current flowing from 0 to I and the stored energy is going from 0 to E. So the limits are 0 to E and 0 to I. So you can write it E is equals to L I square divided by 2. So you can say the inductor energy stored, that is EL, is defined by half Li square. So this is the stored energy in an inductor. Now for capacitor, you can write the same formula for capacitor. For capacitor, this energy is known as P into T. This P is V into I into T. For a capacitor, I is defined by C dV by dt into T. You can write it E is equals to C V dV divided by dt into T. If you differentiate on both the sides, it is C V dV divided by dt into dt. Dt is cancelled out, so this inductor and differential energy dE is equals to C into V dV. If you integrate on both the sides, d is equals to C integration of V dV. So if we applied a voltage for a capacitor, this capacitor is charged from 0 to V and inductor, so and the stored energy is from 0 to E. This is the limit 0 to E and this is the 0 to V. So the energy formula is CV square divided by 2. So here we get the formula for stored energy in a capacitor, that is EC is equals to half CV square. So this is the basic concept of power and energy in an electrical circuit. Thank you. Please like and subscribe my channel.